Can you hear me?
Yes.
Yes, I can hear you.
Very good. I decided to have this class for some unforeseen circumstances. So we can start now. I believe some of you have already joined. Just a minute, let me take care of these few things here. Okay. All right. Let me show you what I have tonight. Oh, a minute. Right, take care of this. There are more people joining, so I'll admit them. Okay, good. So many pages I put. All right. So this here are what we have tonight. I know you can see the screen. For this week, we'll be and I'll be at chapter 7, which we started last week. And for assignment, class work 8, which out as soon as we finish the classes. And then homework 7. They are all due on April 3rd. Now, you can begin your project because we have covered enough ground for you to. Let me show you how the plot looks. It's basically a few points, but you're gonna need a data set that you use to answer those questions. If we go to the assignment page, I believe I have uploaded a project for you. You can see where you have the project right here. So this is the project itself. If you download it, you see the project questions. Let me open it for you. Now you can see the questions that you answer with it for the project. So to answer these questions, there are many of them. You can draw your chart on Excel and then copy and paste it here. Then these are the questions you answer. You can copy on Excel and paste it, type in the answer here, and so on and so forth. So these are the questions. Now, I will show you the data set. I hope you are able to, you will see projects. Do you see the project where I was showing it? Hello, scholars. Can you see the?
Yes.
Hello. Yes. Okay, good, good. Now, the data set need to answer these questions in the project. I'll show you that one now. Here is the open too many pages. Here is data. So you got a download data set here. Is in Excel, in Excel, as a matter of fact. So it's open it. So as you are doing the project, when you get to the point where we have area that we can cover index, you can stop until you cover that area. Then you can now continue. So here is the data set that you need. It is less in miles of 30 rivers in the United States. So this is what you need to answer those questions on the project. So again, the earlier you start, the better for you. It is due on May 15th. So having shown you that and the assignment that I'll do this week, we can now begin our class. Last week, I introduced normal distribution. We did some examples, and we did the applications of normal distribution. We did an example there, and I gave you a classwork. Now, we are continuing with topic. Today, it will be starting from finding data values using given that when you have the specific probabilities. The formula for that is x equals z times delta plus mean, where z represents the standard curve, delta represents the standard deviation, and mu represents the mean, and s is the value you are looking for. So how do you do it? Let's do some example here. The first question we'll be answering is number 9. Yeah. So number 9 is, it says, let me make it big. Make it bigger than 14, make it probably 16.
Excuse me.
Yes,
Can
ma'am.
you record the meeting?
It's being read. It's being recorded. Why? Hello?
Okay.
Why do, okay, you need a copy of the right? Hello? Anyway, so we have, so to qualify for police academy, candidate must score in the top 10% on a general test. The test has a mean of 200 and the standard deviation of 20. Find the lowest possible score to qualify. Assume that the test scores are normally distributed. So the first thing is to write down the value for mean, delta, and x. X is the one you are looking for. So mean, delta, and z score. So anyway, it says that mean, which you can get from here. The symbol is right here. Mean is 200. Okay. And the variance, standard deviation, which you can example here as well, is 20. Then the can score in the top 10%. So the gain probability, top 10%. So we're looking for x. Before you can get s, we need to get z. We're going to use the top 10%, which is 10%. You've given us 0.0. As a matter of fact, I have to draw it. Let me draw it first. So we draw here. Let me make, okay. Then I'm right. I think at least I can move this down. We can have enough room. Let me move it there so we have enough room for this. Yeah. Now, then you put your mean of 0. Okay. So I'm gonna put the x6. You can see it right here. And a mean, now it says top 10% on general ability test. So 10% should be top 10%. That means here should be top 10%. Below it should be 90%. So this is the top 10%. So here you share it. share the area that should present the top 10%. Okay. Right, have this and that. Okay, so this is the top 10%. Top 10%, or you can call it 0.1, okay, which is right here. It is located at this spot here. See the cutoff mark right here. Yeah, now, and then everything will become the 9th. But this is where I look at the cutoff mark, the top 10%, which you are Z. So to find the Z, from what I told from procedure thing, we need to get our table distribution, and then in the procedure table, start the tail. If you remember from last week, you subtract from 0.5. So you're gonna be 0.5, because half of this is 0.5, half of this one is 0.5. So if you're looking for only this small portion, you subtract whatever answer you get from the table of distribution from 0.5 to get only this portion. Minus, but they give us the answer already as 10%, to 0.100. Well, it's 0.10 because there are 40, make it 0.10. So that gives us from our calculator, you know that 0.5, okay, 0.5 minus 0.1 will give us this answer, 0.4. I can see 0.4, which is because there are 4 digits in all the all the values in the table of normal distribution. We write it as 0.4000. Now we go to our table of normal distribution to find the number Z value that corresponds to 0.4000. If we don't see it, we use a number that is closest to it. So let's do the table of normal distribution, and then you can now see that we look for a 0.4000 on that. Okay, statistical. Yeah, wait, tables. That should bring those tables. Okay. We're bringing it up. All right, let's see. Right. I think I have my flash drive, so I'm going to open it from the class. My class, I have it for you in the files section in the classroom. So we have it here as statistical tables. I can load it from there. Yep, it's open now. So I downloaded it for a classroom. Now we go to the table of distribution, which is right here. You can see right here. So make it a little bit bigger. Now look for 0.4 in the table. Excuse me. I got 0.405 and 0.997. I didn't see 0.400, but these are the numbers closest to it. Now, 0.97 and 0.401. This one is 15 points away. This one is only 3 points away. 0.400 minus 399 is only 3 points. You subtract them. But here, if we do 4015 minus 4000 is 15 points. So this one is closer. 0.399 is closer. Now you follow it to the left. You see 1.2 and up 8. So we got 1.8. 1.28. So that's our Z. Now, once you have this number, now you have your deviation, you have your chart where you can get your Z value. Now, to find the possible score to qualify, you apply this formula right here. So I'm going to apply it now, and we get right away. So pasting it here, we can now get so the lowest possible score. Lowest possible score to qualify for this academy is given by the formula. Okay, X equals Z times delta standard plus mean. That means lowest score X score X equals Z. We find it to be 1.28 times our delta standard deviation. Find it to be 20 plus the mean. The mean is 200. So let me write it down, and we can then calculate it from using our calculator. Let me get my papers. So I will have it as 1.28 times 20 plus 200. So write it down. So now we can go to our calculator to get the answer. And have, okay, I'll move this. We can see this. Okay, so we have 1.28. I'll clear this. 1.28 0.2 times standard deviation of 20. Okay, plus the mean of 200. You can see his answer is 225.6. 225.6 points. So that's what you need to minimum score you need to qualify. So we're gonna put it right there, and you can double this with your calculator. 225.6 points. That's the cutoff point. That's the minimum score to qualify for this police academy. Any question on this? Any
Can
questions?
you scroll up to the formula, please?
I'll say it again.
Can you scroll up to the formula?
Right here, it's right here. Can you see it?
Oh, thank you.
You're welcome. So, any other question, class? Yeah, very good. Now let's try an example. It's really different from this one. It says, for the medical study, excuse me. So, for the study, you the researcher wishes to select people in the 60%, in the middle 60% of the population based on blood pressure If the mean systolic pressure is 120 and the standard deviation is 8, find the upper and lower readings that will qualify people to participate in the study. So in this case, they gave you you're looking for two things, the upper and lower readings. So, but in the mind, we will that the mean, I'm gonna put this on the side so I can start copying. Okay, give me 1 minute. Let me move this on one side. Okay, okay. I'll move this one here. Okay. Nice. The mean which you can get from here, the symbol for the mean is this, equals mean blood pressure equals 120 millimeter, and the standard deviation we can get from here as well equals 8. So that we have this. What else do we need? He said the researcher wants this to select people in the middle 60%. So we need to get 2 Z's, Z1 and Z2. So you're going to have the lower and the upper. So you have our Z1 equals, we don't know, and then Z2 equals, since we don't know what they are for now. So we're gonna be okay. This for the both. All right. Now, the first thing we do is to draw the chart. That will press. Again, we make art using this tool here. Okay. So I'll go this way. And then we need the center, the mean, which is 0 always. Then we put our center line and the axis. So I'm gonna put the S as first. And then I'm gonna put the line that represents the mean. Okay, see the top 60%, sorry, the middle 60%. That means left side will be 30% and right side 30%. So that you can get the middle 60%. Okay, so this is 30% here. 30%. You know, I'm gonna put this side. 30%. 30% for the second. So that you know, excuse me, I'm gonna make it up a little bit. 30%, making it 60%. That make it 60%. So you share the middle 60%. I don't want to use color. Let me just use this to shade it, making it more clear. So I'm gonna start from here. The shading part is difficult part. If you know how to draw with computer, it should be a piece of cake. But for people like so doesn't draw very well with computer, I'm gonna try and shade it the best time. But I'm making sure that I understand the point I'm trying to make here. And then what I will send this video to you so that you can watch it anytime you want. The 30%. This is the middle 30%, the middle 60%. Left side, 30 on both sides, making it 60. Okay. And the last line will be what I'm about to shed now. Okay. So that means here, there's 0 Yeah, which is this. Then, okay, then on the right side is Z2. Yeah. All right. Yeah. Now, in this case, the middle 60%, they have given probability already. It is not a tail. So we don't need to try from 0.5 because they give us the probability total already here. So that means Z is 0.3000. Why 0? Because when you look at this in this table here, the table of normal distribution, you can see that all of them have faults. So the zeros in this tray are just placeholders. Now we can number that is closest to 0 to 3.0000. We look for them on the table. If we don't see them, we choose the number that is closest. For example, 0.30, if you ignore this mark point, you can see that this one is 0.299, which is 2995. Now, 300, let's do the math. So have 00 minus 2995. You see that it will be 5 points away. It is 5 points away. Let us replace it with the next number that is closest to it. So next one is 3023. So 303, you can do the math again. 3023 minus 3000. You can see the answer is 23, which is 23 points away. So it's far away. The other one is better, which is 0.29 is closer. So that it is here to the left, 0.8, go up 4, so 0.84. So Z is 0.84. Now, because Z1 is on the left side, we're going to make it negative 0.84. Now, by symmetry, if you remember when I used normal distribution, I told you that it has a symmetric distribution. That means half of this is the other half. So by Z2 will also be 0.4. Now, because it's on the right side, it's going to be a positive number. Now, we have information to calculate the upper and lower ends that will qualify people to participate in the study. Now we can apply this rule here, the same formula we use on the other one, but it's just a slight modification. So we have lower within x1 will be z1 times standard deviation, which we can get from here as this plus mean. Okay, so we can modify the code so I can see it properly. Okay, now I can have this x1, okay, z1, okay, so which means equals our z1 negative 0.84 times standard deviation of 8 plus the mean, which is 120. I'll give you the lower readings. So let's get for the calculator, write this down. I have negative 0.84 times 8 plus 120. So we can get this from our the free calculator line. I'm going to move this up. Okay. So we have it here. Negative 0.84 times the division of 8 plus the mean of 120. 113.28 right now. 113.28 millimeter of mercury. So I got 113.28 millimeter of, that's how you measure blood pressure is in mercury. Then for 2, which is the lower read, upper reading, I can just copy this. I'll save us time and then I adjust this. So I call this one is the upper reading. This is upper reading. Readings. Grab it 2. Then it will be 0, which will be positive 0. Positive this time. And I'm gonna remove this. So we can do the calculator and put this, change the formula to a plus, from negative to positive. That gives us 126.72 millimeter of mercury. So this is the upper and lower readings to qualify 6.72 millimeter of mercury. Any question on this? Hello, scholars, any question? Okay. Now we have 6 minutes left. So 6 minutes is not enough for us to solve one problem. So I'm going to time us out. Please, when I out, wait for 10 minutes, then log back in so that we can continue. Okay?
Professor, before you exit, do you think we have enough time to go over how you use that table?
How I do what again, ma'am?
How did you use the table to find Z?
Oh, this, no, they give us, they give us the probability to be 60%. They made those percent. So on the left side is 60%, on the right side, so the middle side, if 2 of them combined form 60%. So now you go to the table, 30% on both sides, 30% 0.3000, right? So you go to the 2 and look for 0.3000. We can see it. We see only the number closest to it. There are 2 of them, 0.3023, 0.2995. To find which one of them is less, we ignore the decimal point and subtract from 0. So we say 300 2995, give us 5 points. It is 5 points away. Then we check the other number that's closer. 3023 minus 3000 is 23 points, which means that this one is closest. So we choose this one, then follow it to the left. 0.8 and up 4. That's give us the Z of 0.84. That's the Z of 0.84. Now there are 2 of the Z's. One is on the left side. The one is on that is on the left side, we put negative sign for it to show that it's on the left side. That'll give us negative 0.84. The ZU2, which is on the right side, is positive 0.84.
Okay, thank you.
Any other question before I time out?
You said you're gonna log. We should log out for 10 minutes, then log back in.
Yeah, I'm gonna time us out now. Then we'll wait for 10 minutes, then log back in so that we can continue.
Okay.
All right, let me do it, Sam.